Fine. So I'm recording it down. Don't make noise. ABW is 4/3. So that means suppose actual depth is 4 meters. Then there's a shift of 1 meter upward inside the water depth, and you observe the object at the height of at the depth of 3 meter only. That means you're observing the object only at 3/4 of the actual depth. So suppose fish is swimming inside the water, the depth of say 3 meters or 4 meters. Where would you observe it? At the depth of 3 meters only. It will be 3/4 of its actual depth of water. So if I make a diagram for you again, so if I take a water body like this here, and I just put a symbol of fish here somewhere here. A fish is swimming here at the bottom. A fish here. Now its depth is, as you can see, its depth is 4 meters, but you will observe it here somewhere. It is 1 meter upward shifted. It is only 3 meter deep. You can observe it is not here, but you will observe it here at 3 meter depth, because you are not observing the actual fish inside water, because आप तो air से observe कर रहे हैं. जब आप air से observe कर रहे हैं, then you are only observing the virtual image of the fish, which is not at its actual position. It is at the depth of 3 meters only. So if I generalize this statement that every water body, every swimming pool, say swimming pool is 16 meter deep. But we will only observe the depth as 3/4 of the actual depth, that is 12 meters. So it is not 12 meter deep, it is 16 meter deep, but we will observe it as 12 meter deep because I'm observing the virtual image of the base of the pond or of the pool. So swimming pools have a notice pasted somewhere that the pool is more deeper than it's being observed. Have you seen that or not? It is because we are not observing the actual depth of the swimming pool. Rather, we are witnessing what we are witnessing, a virtual image of the base of the pool. Is of course slightly upward shifted. I hope this point is clear to you by this point. So
Yes, sir.
I will,
Yes, sir.
Yes, sir.
my next class, I will take the proving of this relationship between the refractive index of the medium of denser to rare and the apparent depth and the real depth. There's a formula expected from this question in the board exam. Generally, one small formula and one small numerical of 2 marks can be there in the exam. So we'll have some questions in the exercise also. We'll do it later on. Now I take the next topic. There are many topics we will discuss with later on. आपकी book में सब नहीं दे रखे हैं, but I will send you notes of them separately. Apparent bending of a stick underwater. So you dip a pencil, you dip a hand your finger in some water, you put something inside water, you stand inside water, your finger looks like bent away, the pencil looks like bent at the surface. So if I make the diagram here only, say this is a water surface, water body, and you simply dip a pencil inside it. What will happen? Every point inside the water surface will be refracting. There will be a light ray from every point on this stick, on this pencil. I take 2 of them. say from the tip only, obliquely incident at the water surface. I must always draw the normal. I must draw the normal here. Light bends away from the normal because they're traveling from denser to rare medium. And I produce them backward. I produce them backward. And we notice that they meet somewhere here. That means the tip has its image at this point. This also means every point of the pencil will have its image upward shifted from its actual position. I can make the arrows on this. This is the incident ray. This is the refracted ray. They are backward produced. Refraction, refraction, incidence, and incidence. And this is normal. This is normal. This is the image of the tip of the bent pencil. So what is observed is that it seems like the pencil is being bent inside the liquid surface. It is slightly bent at the surface. It seems like this here. Okay, is that clear to you? Fine.
Yes, sir.
So
Yes, sir.
Yes, sir.
now there is a vice versa effect of this also. Now imagine a fish is swimming inside water. It sees a tree outside the water surface, or man is swimming inside water. It sees something, tree or flying bird, or man is standing outside the surface of the water. What happens? A vice versa effect is taken up, and that effect is that that the objects in the rear medium seems to be taller than they actually are. I make a diagram for you very quickly. It's the last for a day. I will take it tomorrow, the next topic. So I make this, say, any surface, water only, red water, doesn't matter, to make it interesting for you. I make it blue. Fine. And then there is an object here at this point, and the observer is inside the water. Say here, this is the observer. Now there is an oblique ray traveling from say where? Rear to denser medium. What will happen to it? What will happen to it? Tell me. It will bend.
Bend towards the normal.
It will bend towards the normal.
It bends towards the normal. And I produce it backward. And what I notice is that object has its image slightly upward shifted here. Now, please remember this diagram carefully. This is a very important diagram. This is a very, very important diagram, right? Your O, your I, please take I. This is not exact to the standard, but you should try to make this diagram like this. Only this is the incident ray. and this the incident, this angle of incidence, angle of refraction. Light is backward produced. This is the virtual image. The virtual image, and we find the image here upward shifted than actually is. All right. There are many more points into them. I will take them tomorrow now. I'm going to end this topic here. Okay, it starts twinkling, that is do not twinkling. The sun is seen above, 2 minutes before and 2 minutes after sunset and sunrise, and the print appears to be raised. Piece of paper stuck at the bottom of the glass slab appears to be raised when seen from above. A tank appears shallow. Person's legs appears to be short when standing in a tank. All these have the same kind of concept behind them. They all have same reasoning, same answer. So in the exam, when you get these questions for reasoning, 2-mark question for reasoning out of them, you must write down the main points inside them. What is the actual reason behind them? And to make an entire story, wrapping it around, but write down the main point that light suffers refraction from denser to rear medium, and the image is formed slightly upward shifted, which depends upon the following 3 factors. This is the perfect answer for that question, right? And so that way this happens in this question. Okay, so what I've discussed with you today, the basic concept behind the upward shift and the factors behind the upward shift and the diagrammatic representation of the upward shifting of the light ray. So please in your copy, practice these diagrams properly. I'll ask you to send me the diagram tomorrow, any one of you. And then what are the reason behind that? And one thing is left in this, that is the relationship between the refractive index and the upward, the apparent and the real depth. A formula required for numericals somehow. I'll take it tomorrow. Today I'm ending it here. We'll just and try to write the answers of 4C exercise now. There are very short 8 questions are there only. You can write down all the answers in this. So write these answers in your exam, in your copy.